everyone. Thanks for joining in on this track. I'm Haribara, and I realize that you're here and you're looking forward to it. So I have been given 20 minutes, but I'd like to talk about what we do at AWS. And I am at Amazon Web Services, and I'm responsible for startup, mail, and quantum solutions architect. And what I do as an architect is that I speak with different customers, and I get feedback from them, and I try to connect that with the global quantum team. AWS does a variety of things, but we have Amazon Bracket, which is a fully managed quantum computing service. I will explain more later. And along with Q2B, we have Stefan, who heads the Bracket team. So if you're interested, please speak with him. Aside from that, we invest in, quantum computing. It's called AWS Center for Quantum Computing. We also do consulting, which is Amazon Quantum Solutions Lab. I will also speak about this. How do you utilize quantum computing in your actual issues? And then we have AWS Partner Network with different partners. So these are overall kind of examples of what we do at AWS. So starting with Bracket, Amazon Bracket. This is Q2B. I'm sure you've heard of it, many of you, but we actually announced it in 2019. AWS always does an end of the year event called reInvent. So in 2019, we announced Amazon Bracket. And at that time, there were three types of devices like this. The basic philosophy hasn't really changed since then when we talk about quantum computing. And I know that you have tested it out, but we don't know what will happen in the future. We don't know which technology will really take the lead. And so as you actually do it, maybe you want to do different types of technologies. It could be superconducting, it could be ion trap, or maybe there's something that's completely new. So you want to really test it and also enjoy it. So you don't want to be locked in with a selection of your device hardware, and you want to do this without any commitment beforehand, and you want to do this on demand, pay per use. AWS's service is basically we have a lot of on demand, pay per use, so we will follow that same philosophy and basic principle. And like I said earlier, so we launched Bracket, and I speak with different customers from startup to enterprise, and please use Bracket and how is it? And with hands-on, I get a lot of feedback from them, and they say that they want to try different hardware and different things. So because of that feedback, this is more recent. This is IQM Garnet, which just recently launched. This is 20 qubit superconducting quantum processor. Gray is a little difficult to see, but you can see topology lattice like this. So here's 4 qubits that's connected. And the characteristic is that of this topology, the fact you can use 20 qubit, it's superconducting, so it's fast, it's bracket on demand use, and unit price is relatively cheap, and fidelity is really good. You can see the numbers for 1 qubit gate and 2 qubit gate fidelity. So this is about 4 track just a while ago, very high in fidelity. So I really recommend this device. Aside from the gated type, Kitagawa-san was talking about this, but we have AHS, KLS, analog Hamilton simulation. You're able to use that as well. It's Acula 26 qubit. It's quantum simulation devices. So it's not limited to a gated type, but you can actually use Bracket on different types of devices. So we do get a lot of different feedbacks. Specifically, what are they? Let me quickly introduce them. So these are the 4 devices that's available: IonQ, Rigetti, IQM, and QR. And the left 3 are gate-based, and the Curata is AHS. It's neutron atoms. And the others are ion trap and superconductors. So basically, you can try different devices easily. And Bracket, you can use skit encoded skit codes, and you can just use it on devices. So you can just easily switch the devices, and it syncs right away. At the beginning, you have it calculate, and of course you want to write the algorithm after testing with the simulator, but you do want to test it with the hardware, otherwise you would not know. And there's an availability window. So when you have this device calculated, they accumulate, and then you see the time in which it takes to calculate. And so you can actually have it calculate anytime, but the device processing time is, Japan time, because you will be able to get that information more on a real-time basis. And when you get that feedback, often the gate type, you can only use it at nighttime. So you stay up really late at night, and then you were using, for example, Rigetti, but it's hard to stay up late at night. So you want to be able to do daytime Japan time. And we had that feedback when it was launched, and we gave that feedback back to the head office. So now it's changed. The availability window expansion has been realized. We are now able to see more coverage in the Japan time. So this is one of the big changes since we launched Bracket. We also have hybrid algorithm available as well. I think with on NISC, that's one of the needs. In order to make it efficient, you have the classical resource as well. So CPU, GPU, we have classical computing cloud available, and you have the brackets, so hardware and simulators. So you can combine them in an optimal manner. And in fact, you can do this on demand, so you don't have to have it launched and then start it up and then pay for it and then just calculate. But just the moment you want to start the calculation, you can just start it up. So you can actually do this effectively, just performance-wise and efficiently too. And from about 2021, this service has been available, and it's a very easy to use function. So depending on how you use, we receive the feedback, and we try to improve our service. So you have used it already, and I know that we have already talked to you, some of you here. So your feedback is for sure reflected in the roadmap. And for those of you who have not yet tried it yet, I live in Japan, so you can talk to me. Or today we have the global team here as well. So if you have a feedback, let us know. Then I think that would lead to the collaborations in the future. And for science experts, so you have the device and you want to book it and you want to use it right away, use it for calculation. So we have a new function called Amazon Bracket Direct, which is a dedicated access for the experts. And you can do this on 1 hour, so like in Q or the other devices. You can just reserve it for 1 hour, and you can have a dedicated access during that time. Aside from that, Bracket Direct has different elements. So hardware provider experts, for example, let's say you write an algorithm and you try to run the device, but you have to understand the device to a certain extent, otherwise you won't be able to get that result. So if you want to optimize your hardware, you have to talk to the IOQ and other hardware the providers, the experts. You want to be able to speak with them directly. So through Bracket Direct, you will be able to actually collaborate and engage with the scientists. Also, we have the Innovation Sandbox, most recent, up-to-date Innovation Sandbox. So you have the availability window set, and in order to use it on a public cloud, it's still at a test stage, but you want to be able to deliver that state of the art. So if it's a completely new device or a new function, through Bracket Direct, you will be able to use it. So specifically, so this is IonQ Forte. This is 36 qubit Eon trap available. So it's Eon trap, but it's a cutting edge device, which is available through Break Direct Cura. This is local detuning function. The potential is controlled, and you have coherence field, which you can set up, or you can increase or decrease coherence. So parameter control can be done on bracket direct. So this is what is cutting edge. So you can start on demand and pay per use, but you can actually have a direct access so that you can have a full use of this device. So this was the functional introduction of bracket, but this session is to introduce how the quantum customers are actually using this. So let me start one by one. So there are different types of customers which I speak with. So for example, startup ISV or enterprises or universities and research institutes and government agencies. I do speak with many different stakeholders, but start from the launch of bracket. Startups are very quick to incorporate new technologies, and they're very ready to use different functions, and they give us a lot of feedback. So startups for us are really important customers from the beginning and even today. And it's they not only use we call this build on bracket. So we would work with many of these startups as a partner. So for example, Kinesis or Genesee or these are the partners we work with, but on global basis as well. AWS partner network is called APN. So all we can do the business together in Japan if they're overseas, or we can work with the Japanese partners and we can do global. So in any case, this is a global collaboration which we support as well. And it's not just partners, but we have Anton Quantum's Solutions Lab. It's a professional service. Helmut Kaflauer, he spoke at last year's Q2B, but his QSL team has supported this one project that I want to introduce to you. I think this is first introduced in the public, but this is Chugai Pharma. Chugai does mid-sized molecular drug discovery. And they use quantum computing to carry out simulation. It's actually a POC study on peptide docking simulation. So can they actually use quantum computing on something like this? And how is it? In order to test this out, AWS experts need to work together. So that is why we were consulted. And as a quantum solutions lab project, we worked together with Chugai. And Mr. Arakawa, Dr. Arakawa was the lead of this project on Chugai's side. And this is their feedback after working with QSL. And based by comparing with the classical and quantum amenable approaches, they were able to fully have an understanding on the potential performance and limits of both approaches. What's interesting is that you don't have to say that quantum was better at this point in time. What we want to know is truth. What is it actually? And I think that's really extremely important at this point in time. And so what AWS is supporting, including AQN, isn't just make sure that it's quantum computing, promoting quantum computing, but we want to know what it is, reality, the status, so that we can explore together with the customers to improve it. And through that, the quantum device, when the performance improves, we can work together and scale the solutions in the same direction. So this is the form of collaboration that we want to carry out, and that's what was realized with Chugai. And so we have startup and enterprises. Here are some more use cases from enterprise. I think we spoke about this last year. This is quantum machine learning with Amazon brackets. So SCSK, they leveraged Amazon's EC2 F1 instances and Amazon bracket IonQ Harmony QPU. And then so they used FPGA to conceptualize simulation. So this is one way to use it. Actually, that was the SCSK. And then for Denso, again, and this is Dr. Kadawaki, he mentioned about this as well. But on this graph, what you can see is here's the comparison between simulation and IonQ's device. So in different areas, from quantum computing to machine learning. It could be Amazon Bracket is used in different areas. Quite interesting. And this is university. Osaka University Center for Quantum Information and Quantum Biology. AWS works with this team as well. But this is a project that is supported by JST, and Kira's QSRCP does different type of things. They do test beds for hardware. They do research, education. What we're introducing here is Dr. Kitagawa is the use of Amazon Bracket on the quantum software creation platform. And what he said, we work together towards realizing a sustainable future society, allows us to easy access to various quantum computing technologies. It is extensive technical support and indispensable for advancing the development of quantum talent. The point here is that it's a bracket that it allows you to use different types of quantum technology. So this is education. So they want to be able to, you know, able to differentiate the strength and weakness of each of the technologies. You know, what it could be used for quality, maybe the difference in fidelity. How can you realize what you want to accomplish with which technology? And that learning is extremely important in education. And I think the value of bracket is realized here. And the fact that Dr. Kitagawa was able to see this was, I would say, he's a visionary, and I think has really understood the importance of bracket when he had chosen us. So this is used at education in Osaka University, and actually Osaka University actually does have a quantum computer. The first was Riken, the second was Fujitsu and Riken collaboration, and this is the third, Japan's third quantum computer at Osaka University. So this is a third, but in Kansai, this is first in that area, and I like to say that. But they have also used AWS, and it's not just used, but we work together on these projects. So. The history of quantum computing in Japan is quite long. There's different researchers and there's a community and there's moonshots and there are many device manufacturers. So the quantum technology of Japan needs to be used not only in Japan widely, but also has to be global as well. And it's really important that it's published like this. And so this is the releasing this on cloud, which is important. And this is not just the Osaka University, but even at Fujitsu, they're using AWS. This is also in the press release, so it's a public information. So they're using AWS on their serverless computing service. So it's not just using bracket for quantum computing, but how do we support the quantum computers that are developed in Japan? That's one of the main responsibilities of AWS. A different perspective, it's not just quantum, but this is classical computing as well. JIJ and startup work together in a simulator, and they used ARM-based Graviton processor to accelerate simulated quantum annealing. And this is quite interesting because optimization of computing is important, difficult. AWS offers different technology. We do CPU, GPU, we do architecture, etc. But the fact that there's option is great because if you choose the right one, efficiency improves significantly. So it's not just quantum, but in classical computing, I thought it would be interesting if it's used in different ways. And one of the examples of ARM is that Fugaku. I think you know this really well, but this also uses ARM architecture. So Fugaku is run by ARM, and there's a ARM chip on Graviton, and so the application by Fugaku is on cloud, and it can also be done vice versa. So cloud HPC, this is what we call it, but this is a supercomputer's technology in Japan, and we have interoperability with AWS. And I think this is quite interesting. So quantum classic can be done on cloud. And this is almost, I'm coming almost towards the end. AWS Center for Quantum Computing is located in Pasadena at campus of Caltech in California. And they do hardware and software and algorithm research. So they do qubit hardware, qubit proposals, end-to-end algorithm survey papers are published as well. AWS in quantum, we want to be investing in strategic machines or business opportunities, excuse me. And we are open to different discussions. We don't, maybe you don't know what you're doing, but maybe you want to consult with us in mid to long term. So you can reach with us. There are three of us here from AWS, the quantum team. So please speak to us if you're interested. And this is my last one. What is the next step? So right now, it's only English online courses available, but you can win a digital badge, and then you can talk to the quantum team. Our team leader is here. If you need to, we can set up a meeting for you separately. And we have introduced example of Chugai about we have quantum solutions lab, which you can work together to introduce partners or explore use cases or do projects as well. You'll be able to encounter the cutting edge quantum computing technology. So these are the three that are here today and this venue today. They're here. So if you find them, please approach them. So that is all from me. Thank you.